Yeah, hello. I think others may not join over today. I looks like people are on holiday or something.
Sir, another class is going on, so I think they'll be joining.
Oh,
Marketing, yes, sir, marketing class is going on.
okay, okay. So we'll wait for a few more minutes. Okay.
Hello, sir.
Yeah, hello.
Yes, sir, we can start the class. Actually, marketing class has got over.
Okay, okay. Let's start. Let me share the screen. Okay. And where is my? Okay, here. Okay, let's do some other. So today, what we will do is some object-oriented concepts. Okay, class, and we'll come back to the files and what program we were doing later. Um, Let me just see if this thing is working fine.
Sir, could you zoom the screen?
Yeah. Okay. Don't know what is this happening. Let me close and open again. I think maybe it's time to create a new file. Now it is really big. Let's create a new file. How do I create new text file? Oh, text file is also an option. Can I run text file? No, there is no option to run it now. So if I want to run, I have to create
So
notebook,
there is option Python 3.
Python 3. Okay, this. Okay, now this is a notebook. Okay. Okay, so from the file, new, and then notebook. Let me run something here to test. Okay, fine. Okay, let me rename this. Can I rename? Yeah, to classes. So that's what we will do today. Okay, actually, I had one Excel sheet where I was explaining. But it's okay, let's explain. I hope you guys remember. Okay, let me put this also so that I can see if anyone is typing. Yeah, I hope you guys remember last time we spoke about classes and object oriented. What is object oriented, right? So class is something inside which you will store the member variables and member functions. So for example, if this is your class, so inside this you'll have so many things. You'll have some member variables, okay, and then you'll have some member functions. So the class name can be, like animal. Okay, so animal is your class. In this, you may have so many fields. Okay, so fields are also, you can call them as attributes. Okay, so you can say like type. What is the type? Is it a dog? Is it a cat? Is it a color? Which color it is? Or multiple attributes you can add, right? These are the types. And then there could be some functions. Like you are asking to do something, right? You can say bark, or you can say speak. So depending on type, if it is a dog, in the speak function you will print bow bow. Or if the type is a cat, in the speak function you can print meow. So the behavior of this, right, depends on the value of these things, right? So these functions will have these values, and then they will do their job accordingly. Okay, so basically the work, so basically these attributes and the functions which are depending on these attributes, they are all bundled inside the class which is called animal. Okay, this is the whole concept of classes and object oriented here. Okay, because this, we treat this animal as an object, then it animal will have some properties, and then there will be some functions, like that. Then you create multiple instances of animal. Okay, you will say, like in you will say d is equal to animal, and then you will say dog. Okay, then c is equal to animal, and then you will say cat. Okay, then when you say d dog speak, in the print you will get bow bow. If you say c dot speak, you will get meow meow, right? Whatever. So basically, you see what we are doing? We are using the same animal, right? But there are two different instances of animal, right? And then we are setting some data, right? And then when the functions are called using d, the same function will behave differently and when you call it through C, the same function will behave differently. Okay, so this is the whole, but this is not the true syntax for Python. This is just a um, pseudocode. Okay, this is not the actual code. We'll do the actual programming in Python, because in multiple languages like Java, C++, C, you have different syntaxes, but this is the concept. Okay, now coming back to okay, let's just leave this here. Now coming back to our code. Okay, I need to take this out so that I can see the chat. Okay. Okay, so now we will create some class. Okay. Okay, before the class, there is one more thing. Okay. That is called scope. Okay. So scope is something. Okay, again, let me make something the same example. Okay, this is one scope. Okay. We'll do the examples in detail, but this is, for example, one scope, and this is another scope. Okay, and this is another scope. Okay, like that. So, and this is your program. Okay, this whole bigger one is your actual program. So suppose you have some variables, x is equal to 40 here. Okay, and then you say print x. Okay, now we know that we'll get 40 as output, right? Now this is another scope. Okay, and the parent of this scope is the red one, right? You will have again x is equal to 50 here, right? And then when you say print, right, x, we will get 50 here, right? So here we will get 40, we know that. Here we will get 50, right? And then another, this is another scope. Okay, same, x is equal to 60 here, and then print x. So this is the local value of x is 60, so we will get here 60. Okay, now again here, suppose I am printing x, right? So what will I get? So first I had 40, then the value is changed to 50, then again the value changed to 60, and now I came back out of that scope. I am back to this scope. Okay, now again if I print, right, it won't show me 60, because right, this scope is only till here, right? Anything I print with this box, it will show me 60, but the moment I come out of this box, again if I print x, I will get the 50. The 60 is no more there because the scope of 60 is gone, right? We are changing the same variable x. Okay, but this time I get 50 because I'm in this scope. Same if I print here again, right, I won't get that 50 back because again I'm out of that scope, right? So we will get here back to 40, right? Now this what I have explained here, right, try to visualize this when I'm doing the programming. Okay, so this is the scope of the variables. Okay, now let's just do this thing in programmatically and see the values. Okay, here let me define a function. Okay, I will say this is my name of the function. Okay, you remember these syntaxes, right? How we define a function? We say def and then write the function name and then this bracket, and if you want to pass some variables, you can pass here. Okay, and then those you can use inside, but for us right now, just this is enough. Now here I have x is equal to let's say 50, and I say print value of x in do something. And what is the value? Let's print it. Okay, and then I'm here outside. Now I'm outside of this function, right? And there is again one more x here also. Print value of x in main. Okay, what is the x? Let's print it. Now see, this is a function, right? So when you run your program, it will not start from here. It will start from here. Then if I call my function, right? If I call my function, then only this code will be executed. Otherwise, this won't be executed. You have to call it. We have just defined it. So definition is different and calling is different. This is the definition. We are just defining it. But unless you call it, this will be never executed. So your execution will start from here. Then the next line, right? And then we are calling this. So again I say print value of x in main before do something. What is the value? Okay. Okay, so this we are talking and trying to understand the scope of x. So see, we have x here, we have x here. Now 2x, and this is a bigger scope, remember, okay? Because this is your main. Okay, this is your main. So this is a bigger scope. So if we see this diagram, this orange color, right? I don't know because of screen share if you see this as a different color, but this color, right? This color is the biggest scope. This is the parent scope of everyone. Now in this, if you see that orange color is this guy, okay, this x, because this is the biggest scope. This function is only till here to here. Okay, so this is a smaller scope, which is, since I am calling it here, so this is a yellow color. Okay, this is a smaller scope. Okay, let's run this. See this line, right? X is 40, right? And we haven't called any function, right? So it shows x 40, right? This is very obvious, right? There should not be any question here. But now I went inside do something. I called do something. So I went here. Now the x is 50 and I'm printing here. So x is showing 50. Okay, this is also clear. Now I came back. Again I'm printing x. So some may get confusion that even though I have changed x here, why I'm getting 40, I should get for 50 because I changed the x, right? But then we need to keep that in mind. This x is different. This x is different. The scope of this x is only inside this function. Okay, not here. Now let's do something, and I will say I will have another function inside this function that's allowed in Python. Okay, do something more. Okay, and I say x is equal to 60. Okay, and I print value of x in do something more. Let's print it. Okay, yeah. Now, but no one is calling it. So even if I run this program, right? Even if I run this program, I won't get the output, right? Because no one is calling this. So someone has to call this function. I just defined it. And let's try that. Let me try calling from here. Do something more. Can anyone tell me what will happen if I run? Error, right? Why? Because it says do something more is not defined. Okay. Because do something more is not directly accessible to you. It is inside do something. Okay. So now you understand what I mean is, in here, in this orange part, if I try to access the green color directly, you can't. What you have access is only to the yellow one, and yellow one is having access to the green one. So yellow one can call the green, but red one can't. Okay, that is how we define the scope and the hierarchy. So when I type something here, uh, okay, let me delete from here. So when I type something here, right, this belongs to this function. Okay, and the moment I come back, my alignment is here. Okay, I'm out of this function, right? So now if I type here, right, I get the value, right? Do something more, right? Do you see here? Do something more. Okay, that is, I called only do something, and do something is calling do something more. Okay, and do something more is having 60. Okay, so you see, here I have got 40, here I have got 50, here I have got 60, right? And if I print here again, print value of x, can anyone tell me what will I get here, or what will be I get on the screen for x? Yes, 50 is correct. Yeah, because I'm back to do something, I'm no more in do something more, so I will get 50 here. Okay, so I hope you guys understood the scope, right? Now what if there is a situation you don't want things to be like this? Okay, you are in this function. Okay, but actually you want to change this x. Okay, not your local x. Okay, what if you want to do that, for example? Okay, so you can. Okay, then let's see that I am here, right? And the next scope of this is this guy, right? I want to change it, right? There is some keyword, okay, which is, let me show you the keyword. Yeah, so there are two keywords. One is non-local, okay, and one is global. Okay, there are two keyword, and then you have to mention the variable name. So in this case it will be x. So you have to mention what is this. Now if I say non and then no space, it's a single word, non-local x. Okay, now my x is this. Now I said non-local x and I'm doing something with x. Okay, now do something more x, right? Let's just focus on, when I display, when I run this program, just focus on do something more this value. Right now it is 60, right? Okay, so it will be 60, but we are actually not modifying, creating a local of this thing. We are actually modifying this guy, the parent. Okay, so yeah, value of x in do something after do something more. Okay, can we hide this part? Okay, let me just shrink it. Oh, beyond this it won't go. Okay, so So now when I'm printing here, I will get 50, of course, right? But now I'm running this function, and this function has done something. Okay, it has done something to my x. Okay, and I'm printing x again, right? Let's see this. So this there is when I'm inside the do something, this is the, okay, I have to reduce the font little bit so that I can show you the output plus program. Okay, just for a few seconds. This font size is okay?
Yes, sir.
Yeah, okay. Uh, So, okay. Now here, right, what we have, right, we have printed first in the main. Okay, so this is not changed. 40 means 40. I have not done anything till now. Now I'm calling do something, right? And do something is printing this guy, right? Now here I have modified it to 50, 50, right? Then I am doing do something more, right? This is called from here. Okay, so I got 60, right? Now I came back to do something. Now I'm not in do something more anymore, right? I am in do something now, and I printed x, and you can see that it is retaining the 60. So whatever this guy did, right, that value continues to be in x, right? Not like before. So here it is 60 now, and then when I come back here, this part, right, when I come back here, again I am got 40. I have got 40, which is this one, right? So when I say non-local here, this means this guy. If I say non-local here, okay, this will mean this will mean this x. Okay, so you got the non-local thing, right? Any question for non-local? Okay, let's do global. What is global? Okay, if I type here global, now see, this is this guy x. Okay, the parent is do something, and parent of that is main, right? First let's just run it. Okay, now this is interesting. See what it did, right? um Here 40, okay, as expected. In fact, I can just delete it. This is very obvious, right? It will be 40. It will never change. Now when I call do something, right, I come here, right, and this will print me this local one, right, 50, which it is doing, right? After that I call this do something more, which is making it 60. Okay, 60 it is. Now when I come back to this one, right, I still have 50, right? And then when I come back here, surprisingly, it is 60 again, right? So basically what I'm saying is, if I type here non-local, it will change the parent, right? If I type here global, it will change parent then parent, this guy. Okay, so that's why for the bottom last one I have 60. Okay, my 40 is gone from here, but this one remained unchanged. It was 50 here, okay, and it was 50 here also. You see 50 here, and after calling this also it is same 50. Okay, any question in this global, and how do you understand the scope, I mean, and then modify the things accordingly? Any questions here? Okay, now, okay, so you have okay, now this was the scope. Let me move to the classes. Okay. Actually, let me have just simple. Otherwise, you know what? If something gets, um, I'll just rename it to scopes. Okay, and then again, let me create a new one. File, new notebook. Okay, I rename it to classes. Okay, now we'll do the classes here. Okay, so classes, there is a keyword here, class. Okay, now like function when we are defining, right? We were typing def, right? But in case of class, when you're defining, you will use class, not def. Okay, so it's different. Now when you give a keyword, you have to give some name. Okay, maybe you can say animal. Okay, now and the same thing, this colon will come, right? Because that's how we are doing everywhere. See, the colon we have to do. Okay, now in this alignment you have to write everything. The moment you come out of this alignment, you are out of this class. There is no bracket. Okay, so now inside this you can have member variables and member functions. Okay, so member variables, like now at or okay this thing, member variable, when I say, that means attribute of animal. Okay, what kind of attribute we can have, like type. Okay, if I say type, okay, and what else, let's just initialize it with animal. Okay, if, and then color. Okay, now okay, let me just explain one more thing here. Okay, one more thing here. Yeah, now that's it. Okay, that's enough for now. I'll come back, okay, here, and I will say d is equal to animal. Okay, or before that, let me explain you this. Print animal dot type. Okay, so now I created a class. Okay, in this class I have one variable, right? And I initialized it to something. Okay, then using this class name, okay, I'm accessing this variable, right? So when we talk about class, right, there is a class and then there are instances of the class. Okay, so again let me try to explain here. This is the class we have defined, for example, right? And then I can have multiple instances like dog, cat, blah blah, so many. So they are instances, right? So then there is some data here like type and all these things, right? If I try to access using this class name, these variables will have some value. Okay, and if I try to access them through instance name, they may have some other value. Okay, so okay, let me write a small program and then show you. So I will say d is equal to animal. So this is a syntax you have to remember. You have to write the class name here and then a bracket. Okay, and then when you say animal type, that is what you got on top, right? I will say d dot type. Okay, now I'm not saying animal type, I'm saying d dot type, right? I created one instance of animal. Okay, now when I say instance, right, that means my own copy. And when I say my own copy, I have rights to modify the value according to my choice. I can change the values and then I can have more copies. C is equal to animal. Okay, and then print C dot type. Okay, let's run this. Okay, now see, same type I'm accessing. Okay, but then you have to understand the scope here again. Okay, this is the class level scope. Okay, this is the type for this instance D, and this is the type for this instance C. Okay, now let me change the copy here. I will say dog. Now let's run. Now this will make you guys clear. Okay, I initialized this at animal, then I created a copy of this or instance. Actually, don't say copy, the actual technical term is instance. Okay, instance. Literal meaning is a copy only, but people talk and call it as instance. Okay, so instance of animal, and in that instance I'm free to do whatever I want. Okay, and whatever I'm doing here will not affect other instance. Okay, now I created two instances here. In this one I said dog, another I said cat. So for the class level I still have this value. For dog level, when I say type I get dog. When I do the cat I say cat. If I create a third instance here, right, animal, and I don't initialize it. Okay, I try to print. Can anyone tell me what will I get here now?
Animal.
Yes, yes, yeah, right, because I didn't modify it, so the parent scope will be in picture. Okay, now normally what we do, we maintain it separately, right? That is a good practice. Okay, it's not a, I mean, Python will not stop you to do anything like that, but the good practice is you maintain variables which are meant for class level and the variables which are meant for instance level, right? You maintain it separately. Okay, don't club it here. Okay, so let me write here. There is a keyword underscore underscore init underscore underscore, like that. Okay, let me see if I've written the syntax right. Yes, underscore underscore init underscore underscore, right? And then this function, you can type here anything, it doesn't have to be just self, right? So this function, right, if you are defining inside your class, okay, you don't have to call this. It is a shortcut for initialization. Okay, you don't have to call this, the Python will call this function automatically. Okay, so we won't call this, and this is a keyword underscore underscore init, you cannot use it as your own function. Okay, now in this I will have some variables. Okay, I say color is equal to, no, not just color. If I just say color, it will be just for this function, but I want self dot. Now when I say self, right, self means this copy dog. So self of dog is separate, self of cat is separate. Okay, so whenever you are modifying something using self, it is modifying only for your instance, it will not touch the other instance. So I say self dot color, and then you can pass multiple parameters after this. Okay, and then I get color. Okay, so I will say color. Now, now remember this color is different, and inside the self color is different. Okay, so like this I am saying, right? Now when I have done this, right, now I call here dog, so I don't have to do this, right? So, and then let's call it a cat, then let's call it mouse. Okay, now the type of DCE, right? Whenever you print type of those, right, it will always be animal. Okay, so whatever thing you want to share between your instance, common things, okay, whatever common things you want to share between your instances, you keep it here. Okay, this is the practice. It is not a compulsory thing. Python will not tell you anything, even if you want to do something in your own way. But this is a good practice, that whatever you want to be to be common for all the instance, you keep it here. Okay, and then whatever you want to have only for that instance, you keep it inside the init. Okay, so you will create one instance color, and whatever you're passing I have assigned here. Okay, like that. So let's just color. Okay, let's see whether this guy has color or not, because we didn't create color right from here. Okay, so when you do like this, one attribute will be created and will be given to D. Another time, next time when you call this statement, one more attribute color will be created, and that will be here in C. So everyone has its own copy. Okay, like this. Any questions here till now? Getting confused or it's okay? Yeah, okay. So okay, let's move on. Okay, um okay, this is one complex example, but it's okay, the concept is same. So also you can change later on your own um, values. Like if I say d dot color, okay, is equal to, oh, for color I said dog, cat, mouse. Okay, anyway, so d dot color, if I say black, okay, right? So now if I print the d dot color, right, so it will be black. Okay, now others are not affected. That's the thing, right? So you can change it directly by using d, or whatever you do inside this, you will change it like that. Okay, this is your scope, you can change it. Okay, now coming back to function. Okay, now these are the, this was also a function. Okay, but this function is a special function. This will be called uh, automatically by the Python. Okay, you don't have to call, but you can have other functions also. Okay, like I was saying, right, I will define my function, and what it will say, speak. Okay, and then when you say this is speak, print. Okay, now let's see how it behaves. If I say, okay, let me copy this, put it in another one, and remove unnecessary prints. Okay, so if I say, if I'm just calling d dot speak, so now if I, okay, but now if I say with cat dot speak, okay, still bow bow, right? But we don't want that, right? We want, depending on the cat, dog, or whatever, you should tell me that, right? So if self dot, okay, actually this should be type here, their own types. Okay, any common animal properties right now we don't need, will don't need this. Okay, and then I check if self dot type, okay, is double equal to what it can be, it can be dog. Okay, if that is the case, my print is good. Okay, these if else if all these things you guys understand, right? These conditions. Okay, now if it is a cat, okay, so now if I call it through using D, I get bow bow. If I call it through using C, I get meow meow, right? So the self, this is an important variable actually, okay, which you have to understand. Whatever you have done in here will stay in self, and the self of D, self of C, and self of E, all of them are different, and whatever you are storing for D in the self will have its own copy, and self of C will have its own copy. So when you come here and check for self type, right, you can be sure that when you are calling using D, the self will have dog, right? That you can be sure, and Python is making sure that it will have dog, not cat. Okay, so similarly, if you are calling it through C, it will have cat, not something else. Okay, this is how you create your own function. Okay, so you have to have one mandatory function. So as you saw right in here, when I try to create a function without any parameter, right? Right, when I try to do that, it will not allow me, right? Because in this case, if I do something like that, right, the self is like mandatory. Okay, you won't get the error until you call it. Okay, if I call, I get the error. So Python is, that's why Python is different than other programming. If you have any error, you may get the error without calling also, but in this case you will have to, you'll get the error when you call it. If I say d dot speak more, okay, it says takes 0 positional error but expected 1, so 1 is required. Now what if I pass d? Okay, no, but you are, I have to mention here, right? Okay, let's don't do that. Okay, now what if I try to call using animal? So I am trying to call this using the class, okay, not through any instance. Okay, if I try to call like this, okay, then it is allowed, no error, right? You see the scope thing here. So the function which you have defined like this without a self, right, that is expected to be called only by using the class name, okay, because this is a higher scope, class scope. But if you have used self, okay, then you can call it using instance. This concept is okay. So let's try to call animal dot speak, right? Now here we have defined speak with self. That means this is meant to be called by instances, but we are calling speak directly using the class name, not through any instance, right? So then the same thing, what you get, right? Okay, now let me try passing d, this one instance, and I'm okay, right? I get bow bow. If I pass, see, I get meow meow, right? So that means if you have defined a function like this, right, which expects self, right, you have two options to call. One is use instance like this, okay, and don't pass anything. That means self is d. Other option is you are calling using your class name, okay, and then calling that function. In that case, you have to mention for which instance. You have to mention the instance name. Otherwise, it will complain. So I am telling call speak for C. Right. This is the two options. This is how the scope and functions will work. So we have covered member variables of class and then variables of instances and then functions. In the functions, two type. One is which is supposed to be called by instance. One is which is supposed to be called by common using the animal name, not through the instances. Okay. We'll see some more of the classes and then we'll go to our original problem of files, what we were doing. But this time we will use objects in file, not like the records how we were using. Okay, we'll use these classes, create objects and functions properly, and then we'll modify the files and create records in that. Okay. Any questions till now for classes and scopes? This was actually important concept which you should remember. And this concept is like for all the programming language, not just Python. Just the syntax is different here, but the concept is common. Any
So can
question?
you send the file us?
Yeah, yeah, yeah.
Yes.
uh, so I have to save, and then I have to send classes and scopes. Let me go here. classes and scopes. What is the date? Okay, 21st. Okay. Okay. Tomorrow is a holiday or Sunday is a holiday? I forgot. Smita told me.
Tomorrow is holiday, sir.
Tomorrow is a holiday. Okay, so we'll meet on Sunday then. Okay.
Actually, sir, when we are going to start the analytics?
Yeah. So this is the basics. Okay, of programming, and I think this is the last topic. Actually, there are some.
Okay, so from the next lecture, we are going to start the analytics
No, no.
part.
Still, we have to next lecture finish the files. How you do the file.
Oh,
So after that, we can start. Next topic is okay. These libraries. Okay, these libraries. It's okay. We will actually go to the mathematics library. This is important for analytics. We have other libraries
okay, sir.
also. Error, output, string, date time, data compression, performance measurement, all this. But that's okay. Not required. Mathematics library is the important one. We'll check this mathematical library, what all we have inside this and how to use those functions. And then we'll jump to because we have to use a um, machine learning and AI, right? We have to choose a library first because there are multiple Python libraries available. So I'll
Yes.
do some any recommendation from your university that use this library or learn this library? Because see, in market there will be many popular options that use my library, so you can use multiple libraries. So but if there is any recommendation, we will use just that library.
No
Otherwise
idea,
we
sir.
no
Sir,
idea.
actually, it might be mentioned in the syllabus.
Syllabus, okay, let me go through that one properly. Okay. Or other, if nothing is mentioned, I'll speak to Smita or someone, and then I will choose one library, and then we'll explore that library. So even if we cover one library, right, if another library is there, that may be more or less similar, maybe some function name or something might be different, but more or less similar. But we will choose some popular library which is popular nowadays. But you don't know, like, after 6 months, after one more year, the same library is popular or not. You don't know that.
Yes.
Okay, fine. So we'll break. We'll meet on Sunday.
Thank you, sir.
Thank you.